Good day everyone, welcome, and today we will be discussing the topic combination. Combination. Unlike permutation, in combination orders or repetitions are not allowed, that is AB is equals to BA. Also recall that combination is denoted by NCRO, which should be equals to NRO, which should be equals to N factorial divided by N minus RO factorial, RO factorial. The relationship between permutation and combination is N combination RO is equals to N permutation RO divided by RO factorial. Now for our very first example, we have the question that says that in how many ways can a disciplinary committee of 3 be formed from 10 members of staff of a college? Now for our solution, the members of committee are always the same since there is no condition placed on the membership. Now this is a combination problem, so it means 10 combination 3, which should be equals to 10 factorial divided by 10 minus 3 in bracket factorial 3 factorial, which should be equals to 10 factorial divided by 7 factorial 3 factorial, which should also be equals to 10 times 9 times 8 times 7 factorial divided by 7 factorial times 3 times 2. 7 factorial in the denominator and the numerator will equate out, so it will be equals to 10 times 3 times 4, which should be equals to 120. Our second example states that in how many ways can a committee of 3 maths teachers and 5 chemistry teachers be formed from 6 maths teachers and 10 chemistry teachers? Now for our solution, the maths teacher can be selected in 6 combination 3 ways, and the chemistry teachers can be selected in 10 combination 5 ways. So therefore our number of ways will be equals to 6 combination 3 times 10 combination 5, which should be equals to 6 factorial divided by 6 minus 3 in bracket factorial 3 factorial times 10 factorial divided by 10 minus 5 factorial 5 factorial, which should be equals to 6 factorial divided by 3 factorial 3 factorial times 10 factorial divided by 5 factorial 5 factorial. Expanding our factorial, it will be equals to 6 times 5 times 4 times 3 factorial divided by 3 times 2 times 3 factorial times 10 times 9 times 8 times 7 times 6 times 5 factorial divided by 5 times 4 times 3 times 2 times 5 factorial, which should be equals to 5 times 4 times 2 times 9 times 2 times 7, which is equals to 5040. We have another example that states that out of 9 teachers and 5 principals, a committee consisting of 4 teachers and 3 principals is to be formed. In how many ways can this be done if Roman figure 1, any teacher and principal can be included? Roman figure 2, one particular principal must be on the committee. Roman figure 3, 2 particular teachers cannot be on the committee. Now for our analysis and solution, for Roman figure 1, 4 teachers out of 9 can be selected in 9 combination 4 ways, and 3 principal out of 5 can be selected in 5 combination 3 ways. Hence the required number of ways will be equal to 9 combination 4 times 5 combination 3, which is equals to 1620. This is pretty straightforward, so there is no need expatiating at. Now for Roman figure 2, there is no restriction on teachers. Hence each selection is 5 combination 4 still as before. Since one particular principal must be included, we are left to choose 2 additional principal from the remaining 4, which can be done in 4 combination 3 ways, which will be equals to 9 factorial divided by 9 minus 4 factorial 4 factorial, that's for 9 combination 4, times 4 factorial divided by 4 minus 2 factorial 2 factorial, that's for 4 combination 3. So this will be equals to 9 factorial divided by 5 factorial 4 factorial times 4 factorial divided by 2 factorial 2 factorial, which will be equals to 9 times 8 times 7 times 6 times 5 factorial divided by 4 times 3 times 2 times 5 factorial times 4 times 3 times 2 factorial divided by 2 times 2 factorial. The factorial in our numerator and denominator will cancel out, so we'll be left with 9 times 2 times 7 times 2 times 3, which is equals to 756. For Roman figure 3, since 2 particular teachers cannot be on the committee, we are left with 7 teachers to choose 4 from, and this can be done in 7 combination 4 ways. There are 5 combination 3 ways to select the principal since no condition is allowed. So our selection will be equals to 7 combination 4 times 5 combination 3, which will be equals to 7 factorial divided by 7 minus 4 factorial 4 factorial times 5 factorial divided by 5 minus 3 factorial, 3 factorial, which will then be equal to 7 factorial divided by 3 factorial, 4 factorial, times 5 factorial divided by 2 factorial, 3 factorial. This will be equals to 7 times 6 times 5 times 4 divided by 3 times 2 times 4 factorial, times 5 times 4 times 3 divided by 2 times 3 factorial, which will be equals to 7 times 5 times 5 times 2, which is equals to 350. Our final question is from UME 1992, and it states that a student has 5 courses to take for mathematics and physics. There are 4 courses in mathematics and 3 in physics, which he can choose from at will. In how many ways can he choose his courses so that he takes exactly 2 courses in physics? Now, for our analysis and solution, the student must take exactly 2 courses in physics out of the 3 in 3 combination 2 ways, and will be left with 3 courses to take in maths out of 4 in ways 4 combination 3 to complete his 5 compulsory courses. The 3 courses in maths and 2 in physics are the same no matter the arrangement, and this is a combination problem. So our number of ways will be equal to 3 combination 2 times 4 combination 3, which is equals to 4 factorial divided by 4 minus 3 factorial, 3 factorial, times 3 factorial divided by 3 minus 2 factorial, 2 factorial, which will be equals to 4 factorial divided by 1 factorial 3 factorial, times 3 factorial divided by 3 minus 2 in bracket factorial, 2 factorial, which will be equals to 4 times 3 factorial divided by 3 factorial, times 3 times 2 factorial divided by 2 factorial. Our factorial in our numerator and denominator will cancel out. We'll be left with 4 times 3, which is equals to 12 ways. Here are some exercises for you to try your hands on at home. And for more insight on this topic, you can check out our Hidden Facts Further Mathematics textbook. You can get the hard copy in bookshops, or if you are interested in the soft copy, you can get it at the website on the bottom of the screen. Thank you.